This combination of functions is probably already second nature to anyone that does any serious financial modelling. So this session isn't really aimed at you or anybody like that. However, if you don't currently use index match or don't understand why you might use it, then please stay with me. So what does this combination do and why do we use it? In fact, what it does is to achieve the same aims as traditional V and HLOOKUP functions. It returns a value from a range or table based on a lookup value. So why do we bother using this slightly cumbersome combination of functions if there's a perfectly good inbuilt function already present? Well, it turns out that VLOOKUP and HLOOKUP aren't necessarily quite as perfect as we might have hoped. In another session, I explore the challenges of using those functions, but in summary, they require an entire table to be referenced. They require the return range to be placed to the right of, or in the case of HLOOKUP, below the lookup range. And 3, typically the return range is input as a static number. None of that is ideal. As modelers, we tend to like flexibility and we like efficiency of calculation. The combination of index and match gives us both. So, how does this combination of functions work? Well, there are 2 elements, index and match. I bet nobody can see that coming. Firstly, let's look at the index. Well, the index returns a value from a specific place in a list or a range. E.g., it returns the 5th value from a list of, say, 10 items. And match returns the place in the list where it finds the lookup item. Thus, I think you can now see the similarity between this combination and, say, VLOOKUP, which essentially looks down a list of items until it finds the lookup, say the 5th value in the list, and then looks in the return range for the item that's located in the same place, i.e. the 5th item. This will make much more sense with a worked example. So let's do that. You'll see that I've created a very simple table of temperatures in Celsius, Fahrenheit, and Kelvin. We'll input the values in Celsius and return a value in Fahrenheit. Because we have 2 elements to this, I've separated the components to hopefully show how the combination is constructed. Well, let's start with the match function. Here, as mentioned before, I'm looking to see where I can find the lookup value in my lookup range. So let's write that element. We say equals match, and then my lookup value is going to be my cell D2, and then I'm going to point to my lookup range in cells D8 to D18, and then finally, because I'm looking for an exact match, I'm going to put a 0 in there. Okay? Right. Let's just put a value in for Celsius just so that we can sort of see it working. And you'll see that the match comes out with a value of 6. And if you look down my list of temperatures, you can see that 1, 2, 3, 4, 5, the 6th value is indeed 5. The second element of this particular combination is the index component. As a reminder, in simple terms, the index function returns the value from the nth element of a list. So, using the match function, we determined the lookup value was the 6th item in our lookup range, so we need to find the 6th item in our return range. And you can see, as I've shaded it here, 1, 2, 3, 4, 5, 6, the value should be 41. So let's write that element. We say equals index, and again I refer to my return range, and for this, in this purposes, I'm just going to refer to the match value that we picked in cell D3. And you'll see that, absolutely right, my index returns a value of 41, representing the 6th item in our return range. So let's put all of that into a single formula in D5. In fact, although I could just type the full formula, I'm going to construct it in the same way as I have done for 2 separate components, as this is really good practice, and perhaps more importantly, allows us to spot errors as we go. So again, here I'll start with my match function. The value in D2 against the value in my lookup range. Again, I'll zero it. Again, it's 6. Of course it is, because that's what we did in cell D3. Then I'm going to build the index function around it. Okay, so I'm going to say equals the index of my return range, comma my match. And you'll see that we get the same answers yet again. So, broadly, there it is. What I will say is this: where you have an extensive use of this combination of functions, I would suggest that you spend a little time thinking about the design of the calculation, as the match function can be quite overhead intensive. A few years ago, I was given an hour to fix a model that another person had built that was taking nearly 9 seconds to recalculate. With some simple redesign and the removal of unnecessary repeated match functions, I achieved a recalculation time of under 1 second. Still a bit slow, but definitely better, and with a bit more time, who knows? So very broadly, that is the simple use of index match combination. It's more flexible than VLOOKUP, but to a non-modeler, this combination can look a little bit daunting. I even had a client who described themselves as an experienced modeler say, I just wasn't sure how this worked. So in many cases, I've moved away from this combination of functions and moved towards using XLOOKUP. And please see my sessions on the use of that function, and please also see my other sessions on other functions that are useful to financial modelling.